Hello children, how are you? I hope you are all fine and safe. I welcome you all to an interesting and important part of physics. Without this, you can't see anything in and around us. This is very important. The main source of sun, it beautifies the world very much. You have learnt about this from lower classes. I hope you understand what we are going to see today. It's light. So far up to 9th standard, you studied about light, but in 10th standard, the name is little bit changed to optics. What is meant by optics? Optics is a branch of physics that deals with the behavioral changes of light and its application. What is meant by behavioral changes of light? It's nothing but the change in the properties of light and its application. So, these are all the basic things already you have learnt in lower classes even up to 9th standard. So, in this session we are going to see about refraction of light, the laws of refraction, that is first law and second law, already you studied in 9th standard. Then dispersion of light, scattering of light, the types of scattering and lenses, the types of lenses, the advantages of lenses, the difference between the lenses and the optical instruments, and one more important thing is the human eye. Let us see or let us recall what are the properties of light or what you have learnt so far. First one, the path of light. The path of light is called ray. This is ray. Group of these rays are called beam. Group of these rays are called beam. Then light travels in a straight line. Already you know very well, light travels in a straight line. Light is a form of energy. Light even travels through vacuum. That is, light doesn't need any material medium to travel. The velocity of light is 3 into 10 power 8 meter per second. Since light is a form of wave, it is characterized by a wavelength, that is lambda. Lambda is wavelength. And the frequency nu. This is not V, it is nu. This is frequency. Different colored light has different wavelength and frequency. Among the visible light, you know visible light which has lowest wavelength. Violet has the lowest wavelength and red has the highest wavelength. VIBGR, do you remember VIBGR? In this VIBGR, violet has the lowest wavelength and red has the highest wavelength. When light is incident on an interface between two media, it is partly reflected and partly refracted. When light is interface, for example, let us take, this is the normal, this ray is incident ray. Already you have learnt in 8th standard also, reflection, you learnt about incident ray. When light travels from one medium to another medium, it is refracted. That is the path of the light. If there is no medium, the path of the light is get deviated. This is incident ray. This is refracted ray. This is called interface. Interface is a place where the two media merges or mingle. Already you have seen 2-3 points only, very new to this class. Next, we are going to see the refraction of light. Already you know refraction. What is meant by refraction? When a light ray travels from one medium to another medium, the path of the light gets deviated. So, you have learnt in 9th standard. So, again this is a recalling part. Refraction takes place. Why refraction takes place? Refraction takes place due to the difference in the velocity of light in different media. Already we have learnt the velocity of light is 3 into 10 power. Velocity of light C is equal to 3 into 10 power 8 meter per second. That is, light can even travel through vacuum. it does not need any material medium. So, the velocity of light in vacuum or air is 3 into 10 power 8 meter per second. Here the velocity of light is more in rarer medium, less in denser medium. What is mean by a rarer medium, denser medium? What is mean by rarer medium? For example, take this diagram. Here if we assume it is air, it is water. Medium you know very well, some examples for medium are air, water, glass. So, these are all some examples for medium. If I ask you, you will answer it. So, here when light travels from air to water, the path of the light, if there is no water here, the path of the light should be like this, like a straight line. Okay. But the water is present here. When light travels from one medium to another medium, it gets refracted. When it travels from rarer medium to denser medium, what is mean by rarer? I already told you, it is a medium where the velocity of light is more high. The denser medium, the velocity of light is low. So, you know this very well. For example, compared to air, a velocity of light in water is low. Compared to water and glass, the velocity of light in glass is low than water. So, the velocity of light is more in the rarer medium and less in the denser medium. So, next we will see the laws of refraction. The first law of refraction, the incident ray, the refracted ray of light and the normal to the refracting surface all lie in the same plane. See this diagram again. The incident ray, the refracted ray and the normal, you know very well about how to draw the normal. These three lie in the same plane, very simple, like the laws of reflection in mirror. The second law of refraction. Now, let us go to see the second law of refraction. The ratio of sine of angle of incidence and the sine of angle of refraction is equal to the ratio of the refractive indices of the two media. This law is also known as Snell's law. Now, before going that, sine of angle of incidence. Here, angle of incidence, you know how to mark it. Angle of incidence is the angle between the normal and the incident ray. This is I, and angle of refraction, sine of angle of refraction, that angle between the refracted ray and the normal. This is angle of refraction. So, here sin I by sin r is equal to mu 2 by mu 1. What is mean by mu? Mu means refractive index. So, refractive index. Here Snell's law. Immediately what comes to your mind? Since Snell's law means sin I by sin r is equal to mu 2 by mu 1. Mu, you know, refractive index of the second medium to the refractive index of the first medium. So, this is called Snell's law. Okay. Next we will see about the Snell's law, what it explains, and then what is mean by refractive index mu. What is mean by refractive index? Thus, it is the ratio of speed of light in vacuum to the speed of light in a medium is denoted as refractive index mu of that medium. Now, we are going to have a formula for mu. Mu is equal to C by V. This is refractive index, definition for refractive. Once again I say this, the ratio of speed of light in vacuum to the speed of light in a medium is defined as the refractive index mu of that medium, that is mu is equal to C by V. Already we have seen C, the value of C in the properties of light. What is C? C is the speed of light in vacuum or air. Here what is V? V is the velocity of light in that medium, particular medium. For example, if light is refracted from water to glass, velocity of light in glass medium. So, next, the speed of light in a medium is low if the refractive index of a medium is high and vice versa. Next point, very important, when light travels from denser medium into rarer medium, the refracted ray bent away from. Light travels from rarer medium to denser medium. When light travels from rarer medium to denser medium, the refracted ray bends towards the normal, When light travels from, this is, if you assume this is glass, this is air, it bends away from the normal. Refracted ray bends away from the normal. So, when light travels from a rarer medium into denser medium, the refracted ray is bent towards the normal drawn in the to the interface. When light travels from denser medium to rarer medium, when light travels from denser medium to rarer medium, the refracted ray is bent away from the normal drawn in the interface. Already I explained you what is interface. I hope you understand very well about the laws of refraction, the first law of refraction, the second law, Snell's law of refraction. Very well. Okay, children. Now, let us go to an interesting part, dispersion of light. What is meant by dispersion of light? You know very well about dispersion of light, but here you must know the two sources of light. Source of light, here monochromatic source of light, composite source of light. What is meant by monochromatic source? Mono means single or one. Chromatic means color. The source of light that emits a single light color, single color of light is called monochromatic. For example, for this is sodium vapor lamp. So, this is called monochromatic light. Composite source of light. Composite source of light is the source of light that produces a light of different colors is called composite source of light. Here example, sunlight and mercury vapor lamp. So, if you understand this, we will enter the part dispersion of light. So, the source of light is classified into two, monochromatic source of light and composite source of light. The source of light that produces a single color is called monochromatic light. Example for this is sodium vapor lamp. Here composite source of light means the light that produces white light of having different colors, that is sunlight and mercury vapor lamp. Now, let us see what is dispersion. When a beam of white light or composite light is refracted through any transparent media such as glass or water, it is split into its component colors. This phenomenon is called dispersion of light. For example, நம்ம ரெயின்போலாம் பார்த்துருக்கலாம். ரெயின்போவில் பார்த்தீங்கன்னா the band of colors, the spectrum of colors நீங்கள் பார்த்துருக்கலாம். So, this is a very simple example for dispersion of light. Now, you understand very well about dispersion of light. The color is called VIBGR, the colors produced by the composite color. The acronym, we are using the acronym VIBGR. You see here VIBGR, V is violet, I is indigo, B is blue, G is green, yellow, orange and red. Why I am marking these three colors? This is lowest wavelength having the violet, indigo, blue. These lights, these colors have lowest wavelength. Wavelength is denoted by lambda. Here, this is highest wavelength. These three colors, yellow, orange and red, highest wavelength. You must keep this in mind. So, if you keep this in your mind, it will be very easy to see the next topic. The band of colors produced by it is called spectrum. The spectrum consists of the following colors: violet, indigo, blue, green, yellow, orange and red. These colors are represented by the acronym VIBGR. Why do we get the spectrum when white light is refracted by a transparent medium? This is because different colored lights are bent through different angles. You know angle of refraction. Suppose, let us see, this is white light entering that glass. It is dispersed into different angle. So, different colored lights are bent through different angles. Example, the angle of refraction is different for different colors. Angle of refraction is denoted by the letter R. You know, angle of refraction is different for different colors. The angle of refraction is smallest for, now here I have written the lowest wavelength, the highest wavelength. These three colors having the highest wavelength. Now, the angle of refraction is denoted as angle of refraction is highest for violet. Violet க்கு ரொம்ப அதிகமா இருக்கும், red க்கு ரொம்ப கம்மியா இருக்கும். Next, we are going to see about the scattering of very interesting The scattering of light only beautifies the world. What happens in scattering of light? You know very well, scatter means சிதறல்னு சொல்லலாம். ஈவன் இன் கேரம் போர்டு நீங்கள் வந்து ஸ்ட்ரைக்கரை வச்சு அடிக்கும்போது த காயின்ஸ் எல்லாமே ஸ்கேட்டர் ஆகிறத நீங்கள் பார்க்கலாம். ஸோ ஸ்கேட்டரிங் இஸ் நத்திங் பட் அப்படியே ஃபுல்லாக தெறிக்க விடுறதுன்னு சொல்லலாம். அது மாதிரி when light enters the atmosphere, what is the reason for the scattering? ஸ்கேட்டரிங்க்கு என்ன மெயின் காரணம் அப்படின்னா, the molecules, the atoms and molecules present atmosphere is reason for the scattering of light. When light enters the atmosphere, Earth's atmosphere, the atoms and molecules of different gases present in the atmosphere refract the light in all possible directions. See the diagram, the scattering of light. So, this is called scattering of light. This phenomenon of beam of light is redirected in all directions when it interacts with the particle of the medium. The interacting particle of the medium is called scatterer. So, scatterer. In the atmosphere, there are lot of atoms, molecules and other particles, water droplets, smoke, etc. are present. So, these particles scatter the light in high amount. Next, type of scattering. When a beam of light interacts with the constituent particle of the medium, it undergoes many kinds of scattering. Based on the initial and final energy of the beam, scattering can be classified as elastic scattering and inelastic scattering. What is mean by elastic scattering and inelastic scattering? The types of scattering, you see the diagram, elastic scattering, inelastic scattering. Inelastic scattering is divided into 4 types: Rayleigh scattering, Mees scattering, Tyndall scattering, Raman scattering. Next, Rayleigh scattering. We are going to see about Rayleigh scattering. The scattering of sunlight by atoms of molecules of the gases in the Earth's atmosphere is known as Rayleigh scattering. Sometimes you will be asked as a defined Rayleigh scattering. So, the answer is the scattering of sunlight by the atoms or molecules of the gases in the Earth's atmosphere is known as Rayleigh scattering. In Rayleigh scattering, we are going to see about what is the reason for the sun looks red in color at the sunset and sunrise, and also why the sky looks blue during the daytime. So, for these questions, we are getting the answer in Rayleigh scattering. Rayleigh scattering states that the amount of scattering of light is inversely proportional to the 4th power of its wavelength. The amount of light. The amount of light scattering is denoted as S. Here we are getting a formula is proportional to, this symbol is proportional to, you know very well, and here if it is நம்ம இந்த டினாமினேட்டரில் வேவ் லென்த்தை கொடுத்துட்டா நம்ம இதை என்ன எப்படி நம்ம ரீட் அவுட் பண்ணணும் அப்படின்னா, இட் இஸ் இன்வெர்ஸ்லி ப்ரொபோர்ஷனல் டு. ஸோ Rayleigh scattering states the amount of light scattering is inversely proportional to the 4th power of its wavelength. So, wavelength lambda wavelength. So, this is an important Rayleigh scattering, define Rayleigh scattering, you have to write the answer and mention this formula. According to this law, shorter wavelength colors are scattered much. So, according to this law, already I told you what are the colors are scattered lower and what are the colors scattered higher. We have seen, no, which are the colors, the violet, indigo, blue having lowest wavelength is scattered much. So, according this law, shorter wavelength colors are scattered much more than the longer wavelength colors. Which are longer wavelength colors? Red, orange, yellow are colors having longer wavelength. Okay. When sunlight passes through the atmosphere, the blue color, that is shorter wavelength, scattered to a greater extent than the red color longer wavelength. This scattering causes the sky to appear blue in color. So, why the sky appears blue in color? Now, the answer is when sunlight passes through the atmosphere, the blue color, that is shorter wavelength color, is scattered to a greater extent than the red color, that is longer wavelength. This scattering causes the sky to appear in blue color. The next point we are going to see an interesting point. நம்ம வந்து இதில் பார்க்கலாம், இந்த ஒரு பாட்டே இருக்குது, இது ஒரு பொன் மாலை பொழுதுன்னு. அந்த பொன் மாலை பொழுது உருவாக்குறது எதிரா அப்படின்னாக்க இந்த நம்மளோட லைட் ரேஸ் தான். அதுக்கு என்ன ரீசன்னு பார்க்க போகிறோம். அண்ட் வி ஆல் வெரி நோ கன்னியாகுமரி இஸ் ஃபேமஸ் ஃபார் சன்ரைஸ் அண்ட் த சன்செட். வாட் ஹேப்பன்ஸ் டியூரிங் சன்ரைஸ் அண்ட் சன்செட்? When light rays from the sun has to travel a larger distance in the atmosphere than at noon. இப்போ noon time நம்ம பார்க்கலாம் ரொம்ப ஷார்ட் டிஸ்டன்ஸில் இருக்கும், we feel very heat and the intensity of light is also more. Whereas during the sunset and sunrise, the distance between the sun and us is larger compared to noon. Hence, most of the blue lights are scattered away, only the red light which gets least scattered reaches us. Therefore, the color of the sun is red at sunrise and sunset. So, this is the reason why the sun looks red in color during sunset, sunrise. Not only the sun, the sky also orange in color. You can see this. So far we have seen Rayleigh scattering. Next we are going to see Mie scattering. This is also very important part, very interesting part also. Why the clouds looks white in color. உங்களுக்கே நீங்கள் நிறைய தடவை கேட்டுக்கலாம், ஏன் இந்த க்ளவுட்ஸ் எல்லாம் ஒயிட் கலரில் இருக்குது அப்படின்றதுக்கு ஆன்சர் வந்து எங்கே கிடைக்குதுன்னா இந்த மீ ஸ்கேட்டரிங் பார்க்கலாம். மீ ஸ்கேட்டரிங் இஸ் ஆல்சோ அன் எலாஸ்டிக் ஸ்கேட்டரிங். வாட் இஸ் மீன் பை எலாஸ்டிக் ஸ்கேட்டரிங்? The energy of the incident light and the scattered light are same, then it is called elastic scattering. What is mean by inelastic scattering? The energy of the incident frequency and the energy of the scattered frequency of light are different, it is known as inelastic scattering. Now see Mie scattering. Mie scattering takes place when the diameter of the scatterer, what is scatterer? You know, the particles are the atoms and molecules. The diameter of the scatterer is similar to or larger than the wavelength of incident light. It is an elastic scattering. Mie scattering is caused by dust, smoke, water droplets and other particles in the lower portion of the atmosphere. Because these smoke, water droplet, dust are present more in the lower atmosphere than at the higher atmosphere. Mie scattering is responsible for the white appearance of the clouds. Why clouds appear white in color? Because in the clouds, what is present in the clouds? The clouds are having lot of water droplets. So, the water droplets, for example, let us draw a cloud. There are lot of water droplets. The water droplets scatter the sunlight equally in all directions. Scattered the sunlight la irukakudi எல்லா colors, all the colors present in the sunlight in all directions equally, which again combine together to form white light, white color. When sunlight falls on the clouds, what is present in the clouds? The clouds are made up of water droplets, you know very well, you have learnt in lower classes. So, the water droplets in the clouds scatter the lights, all the colors present in the sunlight equally in all directions, equally in all directions. So, these scattered lights combine together to form white in color. Sometimes you will have some doubt. Lower part of the cloud appear grey color, because when the clouds will be present in thin layer, sometimes in some places thin layer, in some places thick layer. So, the light will not fall at the bottom of the cloud, so it looks grey in color. The scattering of light by the colloidal particles present. Next, the Mie scattering is responsible for the white appearance of the clouds. Next, we are going to see about Tyndall scattering. This is also very important, you know very well about it. Because why I am saying this, நம்ம எல்லார் வீட்லேயுமே பார்க்கலாம், ஈவினிங்கில் இல்லை மார்னிங்கில் சன்லைட் அப்படியே விண்டோ வழியாக வரும்போது த லாட் ஆஃப் டஸ்ட் பார்ட்டிகல்ஸ் ஸ்கேட்ரிங் ஆகி அப்படியே பறக்கிறதெல்லாம் நம்ம பார்க்கலாம். ஸோ அது இட் இஸ் நத்திங் பட் Tyndall scattering. When a beam of sunlight enters into a dusty room through a window, then its path becomes visible to us. This is because the tiny dust particles present in the air of the room scatter the beam of light. This is known as Tyndall scattering. The scattering of the light rays by the colloidal particles present in the colloidal solution. So, you know you have studied about the solution in chemistry. The types of solution. Here in colloidal solution, the particles are little bigger. So, these colloidal particles scatter the light present in the solution. So, this is called the Tyndall scattering or Tyndall effect. Next, we are going to see about Raman scattering. What is meant by Raman scattering? Raman scattering is defined as the interaction of light ray with the particles of pure liquid or transparent medium. In Tyndall scattering, we have seen the dust particles. Here it is in pure liquid or transparent solids, which leads to a change in the wavelength and frequency. Already we have seen wavelength is denoted by lambda and frequency is nu. Here we are getting some spectral lines in Raman scattering. The spectral lines are one Rayleigh spectral line, second one Raman lines, third one Stokes lines, and the last one anti-Stokes lines. The spectral lines having frequency equal to the incident ray frequency. Underline this, note this, the spectral line having frequency equal to the incident ray frequency is called Rayleigh line. Already you know incident ray, the incident ray frequency. Now it is incident ray frequency, and the spectral line which are having frequencies other than the incident ray frequencies are called a Raman line. So you are very clear, one is Rayleigh line. Here the frequency is equal to the incident ray frequency is called, the spectral line having this is called Rayleigh line. The spectral lines which are having frequencies other than incident ray frequencies are called Raman line. The lines having frequencies lower than the incident ray. Incident ray frequency விட ரொம்ப கம்மியா இருந்தா அதுக்கு பேர் என்னது Stokes line. That means the lines having frequencies lower than the incident frequency is called Stokes line. Next one, anti-Stokes line. The lines having frequencies higher than the incident frequency is called anti-Stokes line. So Raman scattering nalle immediate ungalku enna ஞாபகத்துல வரணும், these lines, these called spectral lines. Okay children, I hope you understand very well. If you don't understand anything, small things, don't get tensed. After the school reopen, you go to your teacher and get cleared. In the next session, that is also an interesting session, we are going to see about the lenses, the types of lenses, the images formed in the lenses, and the uses and difference between the lenses and the uses or the applications. Thank you children.